want to prove this one, and we are having some properties and formula for the row reductions. We'll apply this one and to prove this one. So here we need some algebraic simplification also. So you need the factorization and these all concepts. The problems are not difficult always, but the things that we go step by step, thinking it, planning it, and solving it. So to solve, we need two-step, think and plan, and then solve it. Now we are having the property of the determinant function that we take the transpose, then the value of determinant is not changing. So here in this example, on the left-hand side, we take here left-hand side, and we take transpose of left-hand side, taking transpose. So I plan to write here, because I am making the row operations. So I bring my column 1 and 1. The second row becomes, the first row becomes first column, second row becomes second column. We get here A, B, and C. Third row becomes third column. We get here A square, B square, and C square. So we want to use the row reductions. So we try to bring it in the upper rectangular form so that we can just apply the diagonal elements A1, 1, A2, 2, A3, 3 and get the result. To make this one, we make this one 0 and this one 0. So to make these two zeros, we can have here the next step. I'm going to write it here. So I take minus R1 plus R2 and minus R1 plus R3. So my one first is 1A square minus, we having 0. We have B minus A. We have B square minus A square. Then multiply minus, adding to this one, we get here 0. We get here C minus A, get C square minus A square. Now these things you must know, the formulas. We know that our B square minus A square is equal to B minus A into B plus A, and C square minus A square is equal to C minus A into C plus A. So I just rewrite this one, and we can have here is equal to 1A square, 0 B minus A into B plus A. We're having 0 C minus A into C plus A. Now I have the property I can take common from the row. I take common from the row 1, so I'll get here this equal to B minus A from row 1, C minus A from row 3. What I'll get? I'll get here 1A square, 0, 1, B plus A, then get here 0, 1, C plus A. So my next step is, I just want to make this value 0, so this becomes the upper rectangular form. So I multiply by minus 1, add to this one. So I'll get here this equal to, this result is equal to, we get here B minus A, C minus A, and then I'm having here 1A square, 0, 1, B plus A, and I'm having here minus R2 plus R3. So get here 0, I get here 0, I get C plus A minus B minus A. So simplify this one, I'll get here B minus A, C minus A, I'll get here this equal to 1A square, 0, 1, B plus A, 0, 0, C minus A. So it's my upper rectangular form, just the product of the diagonal elements. That will give me equal to B minus A, C minus A, and I'm having here C minus B, because we're having this A and minus A are cancelled. I get here C minus B, and that's our right hand side. We check this one, B minus A, C minus A, C minus. And there are many questions like this one. This is the only one type of question I'm going to give you. There are many different questions. But the basic idea is more or less the same. And just try, as I said, look on the question for 4 or 5 seconds. Just see what's the difficulty in that one. And then plan your way to solve that one. Use the properties of the determinant, use the row reductions facilities. We're having interchanging two rows, multiple row, and add to another row. And use algebra as we have done this one, and you get the result. So I would like to say one thing that as I give you a few examples, one example I'm giving you more. There are many examples, many type of problems. In your book also, in my notes also. As I told in the beginning that you can just go to the description and you'll get the link, and you can download my notes also. Number 2 is that you like it, subscribe it, and press the button for bell button for the notification, so that you can get the new videos we are developing for the engineer mathematics for you in linear algebra. Also we have differential equation. Also we have made the playlist for that one. You can get the more videos which you have not seen from our playlist. Again, the idea is to do the practice. The practice you will learn, not by reading, not by listening, but here the benefit of these videos is that you can repeat them any number of times you like, and focus is on them. The important thing is to focus. Focus is then you will understand. When you're not focused on, you will not understand. You must have the area in your place of study where you can concentrate. When you concentrate, then we learn and we understand. And try to keep in your mind, give a message in your mind, because there is a difference when you're studying and we are just reading something. There is a difference here. If reading, we can read anything, but study means reading with the purpose. So I take another example for you, and here we use the row reduction to solve this one. The question is without directly evaluating solve by using row reduction using properties of determinant. To show that determinant of the matrix here, B plus C, C plus A plus B, moving A, B, C, 1, 1, 1 is equal to 0. So when you look at the properties of determinant, we are having this property. For example, I have determinant here 2, 1, 3, 0, 1, 2, 4, 2, 6. I say determinant of this one is 0. Why? Because I know when I multiply first row by minus 2 and add to the third row, what will get? I'll get here 2, 1, 3, 0, 1, 2, get here 0, 0, 0. When any row is 0, determinant of is 0. I will say row 1 is proportional to row 3. If we prove this one, row 1 is proportional to row 3, then determinant of the function will be equal to 0. So whatever the function, we have the determinant of that one becomes 0 when two rows are proportional. So here when we want to say determinant is 0, this means we want to show that the two rows are proportional and that becomes 0. So we take here the left hand side solution of this one. We take left hand side. I can see start my plan. We can see we can add these two, get A plus B plus C, A plus B plus C, A plus B plus C. We can take common, and first row and last row become proportional, equal or proportional. So here left hand side, we are having here the operation we are going to make. We add R1 plus R2. That will give me when we add R1 and R2. So I am going to get the equation as A plus B plus C, A plus B plus C, A plus B plus C. And then we're having here A, B, C. We're having here 1, 1, and 1. Now the first row we take here, A plus B plus C common, A plus B plus C we take common. We get here 1, 1, 1. We get A, B, C. We get 1, 1, 1. We say this is equal to 0 because row 1 is proportional to row 3. Or we take one more step, multiply row 1 by minus 1 and add to row 3, you will get the value equal to 0. Wish you all the best for the determinant, and we will just going to discuss the inverse of the matrix That's your next topic by using the cofactor, by using determinant, and that's most important one. Inshallah, she'll see you next time.